Welcome back to our system design series. Today we are going to discuss an important concept called consistent hashing. This hashing technique is a key tool for designing scalable and resilient distributed systems, particularly when dealing with the challenges of data distribution across a cluster of nodes. Okay, so what is exactly consistent hashing? We can say it's a special kind of hashing technique, but let's just try to get an example so we will understand it better. So let's just try to imagine that we have a hash space. Like imagine a fixed circular space or a ring that we will put all of the server on it, and we can have a mapping servers. So each server is mapped to one or more points on the ring using a hash function. So let's just add our server. So let's say that we will have four servers, and we will put them like that. So this is a server 1 or node 1, a server 2, and let make it smaller. No, server 3 and server 4. And we can add some keys. So let's say this is key 1, and this is key 2, and let's just stop it here. Okay, so we have this one we call mapping servers. Like each server is mapped to one or more points on the ring using a hash function, and we map them right now. The second thing, we have mapping the data, because we did map the servers. We want to map the data. So each data item that needs to be stored is also hashed to a point on the ring using the same hash function. The result of the hash determines where that particular data items falls on the ring. And after that, we need to find something we call a data assessment. Like the final step is data assignment. Once the data items is mapped onto the ring, it's stored on the on the first server encountered while moving clockwise. So the key 1 will be stored at server 1 and key 2 will be stored at server 2. And once and yeah, as we said before, once the data item is mapped onto the ring, it is stored in the first server encountered while moving clockwise from the data item's position. This means that each server is responsible for storing all data item that are mapped to it until the next server on the ring. For example, as you can see, if we have another key, let's call it key 3 will be stored at server 1 as well. If we have here key 5 or key 4, um, K4, if we want clockwise, it will be stored at server 3. And we continue doing that. So, okay, a consistent hashing is a special kind of hashing technique that allows for efficient distribution of data across multiple nodes. Unlike traditional hashing methods, consistent hashing ensures that when nodes are added or removed from the cluster, only a small portion of data needs to be reassigned. This property makes consistent hashing especially useful in distributed systems where nodes can join or leave frequently. So, also, if you think right now, the data could be quite distributed, but if we need to make it even more distributed, we can use a virtual nodes. What means that we can have more than one position for one node. So server 1 right now have one position, and server 1 has more than one key value that is connected to it. We can add a virtual node to, for example, S4. So we can this is S4.1 that could handle this key value store or this data. Also, we can do some sort of the replication, because if you think about it, if server 1 went down, only the key 1 will be has a problem with that, will be reflected, but not all the keys. So we still have all the keys, and also we could prevent that from replicating the data. So we can save key 1 in server 1, and also we can replicate it in server 2 as well. So if server 1 went down, we got no problem. Our system is 100% available, no problems whatsoever. So the benefit from this one, first thing, we have minimal data movement. Like when a new server joins or an existing server leaves the cluster, only a small fraction of data needs to be moved. This in contrast to traditional hashing techniques, where changes to the number of nodes often require a complete redistribution of the data. The second thing is scalability, because consistent hashing makes it easy to scale a system by adding new nodes without needing to significantly reshuffle the data over and over and over. This allows systems to adapt dynamically to changing workloads and grow smoothly. And also, it's a great in fault tolerance, because when a server fails, consistent hashing ensures that the data previously stored on the data server can be quickly redistributed among the remaining nodes, minimizing the disruption caused by that failure. So if this is how it works on high level, and if you want to talk about it as a specific example, we can do that. Like, let's consider a distributing caching system. Like, imagine you have a caching system like Redis, or memcache spread across multiple servers. When a new cache server is added to the system, you want the existing data to remain mostly intact with minimal movement. Constant hashing ensure that only a subset of the data cached needs to be moved to a new server, resulting in less rehashing and lower latency during scaling events. So that's it. In this video, we explored consistent hashing, a powerful hashing technique used to efficiently distribute data across the clusters of nodes. We learned about how consistent hashing works by visualizing the hash space as a ring, mapping servers and data to the ring, and assigning data to servers based on their positions. This approach allows for minimal data movement when scaling up or down, making consistent hashing an excellent choice for dynamic distributed systems. If you found this if you found this video helpful, make sure to subscribe and hit the notification bell so you never miss any video. And see you guys in future videos.